Hey guys, I hope you guys are doing good today. So today we are diving into crucial topic how to optimize private to public service traffic in AWS to reduce latency and cost. We will cover the current architecture, problem statement and three possible solutions to optimize the traffic flow. I will break it down step by step, so better to stay tuned. So please do watch out this video fully so that you will get a deep understanding about how to optimize the latency and the cost. So you will get a lot of information without wasting time. So get into the video. Look at the current architecture. Here we have one VPC. We have two subnets. One is called private, another one is called public subnet. So in that private subnet, we have a backend service and the front-end service. The front-end service is running on the port 8000. All are running in a container. Assume it is running in an ECS cluster. Both backend service and the front-end service running in a private network. So it needs to communicate through the external network, basically an internet. So it uses the NAT gateway. And we have something called ALB in the public subnet, where exactly the client request will be routed through the ALB. So whenever the client hits something called frontend.test.com, the request will be routed to the public route 53, where we have a record for frontend.test.com. It is mapped to the ALB URL. So it goes through the internet gateway and then it hits the ALB, and the ALB will route the request to the front-end service. It has the port with 8000 and it is running in the container. The problem statement is all about when backend service uses frontend.test.com to connect the front-end service due to some requirement. Let's take it. So what exactly happened? Whenever the backend service wants to communicate to the front-end service, the traffic goes out to the internet and then it goes to the public route 53 to resolve the frontend.test.com, and then it hits the internet gateway and then it goes to the ALB, and then once again it comes to the front-end service. This seems to be something an odd, and it is having a lot of latency issue, and we have a lot of cost as well, because like it's going through the NAT gateway and latency is also very high. It takes the 2 seconds to reach from one service to another service. We have to cut the cost and parallelly we have to improve the latency. How we can do it? There are three mitigations. Place ALB in the same VPC as the backend, so it is somewhat cost effective. Use service discovery in ECS, which is also a cost effective. So another one is the pretty expensive one, which is to use the PrivateLink. So the first and the most cost effective solution is to place the ALB in the same VPC as where we have the backend. So by configuring the ALB as an internal load balancer, the traffic between backend and the front-end service remain within the AWS private network. So this eliminates the need for NAT gateway and reduce the both latency and the data transfer. To implement this, simply change the ALB scheme to internal when creating and updating it. To eliminate the NAT gateway cost for the backend service or front-end service, since it is no longer need to route the request through the public internet. NAT gateway are built for both data and transfer processing, which can be quite expensive. The traffic remains AWS private network. Avoid internet data transfer charges. Additional cost, none. It is only required reconfiguring the ALB to internal. The net saving is all about reduce NAT gateway and inter AZ data transfer cost. You can look into this particular diagram where we have a private subnet, we have a backend and front-end service running in the same private subnet, and additionally we have an internal ALB. So what happens is, like, whenever the backend wants to call the front end, it will have that frontend.test.com in the internal route 53 record. So it is completely under the VPC network. It won't be exposed outside of the public network. When backend service call the frontend.test.com, it will go to internal network of route 53 and then it will route it to internal ALB and then it goes to the front end. So this is the one way that you can cut the cost and improve the latency. The second mitigation is all about use ECS Service Discovery. So this is the second solution where you can consider it. With this feature, ECS automatically register your service in private route 53 DNS namespace instead of backend service using the public domain like test or something like that, .com, something like that. It can be used a private domain such as test.local to directly resolve the front-end service IP address. So this approach is completely bypass the ALP of inter-service communication, reducing the latency further and saving the cost on NAT gateway and ALB data processing. How to set it up? This is pretty simple. Enable the service discovery in ECS service config and update the front-end service to point to the service discovery DNS example like frontendtest.com.local or whatever it may be. Cost effective. The service discovery enables the direct communication between the backend and the front end using the service, the private DNS record, avoiding the public ALB traffic altogether. ECS creates a private Route 53 namespace for the backend service. For example, very simple, the backend service can be resolved the namespace like the frontend-test.sd.com to the container's private IP. The additional cost is minimal and the Route 53 private namespace charges applies. It's probably the 50 cent per hosted zone per month. The net saving eliminates the NAT traffic gateway and ALB related cost of inter-service communication. When you look into this diagram, both backend and front-end service running in the same private subnet, now it is routing through the internal Route 53. Basically, the service discovery is an option where you can enable for each service. It will create a namespace and it will create a DNS record which will be resolved within the VPC. So you just need to use the frontend-test.sd.com which has been created automatically by service discovery. So this will map to the front-end service IP. Whenever the front-end service goes down and it comes up, it will have a new IP. So the new IP will automatically map to the service discovery record. It will happen everything automatically. So we no need to make any changes in our DNS record. So there won't be any issue, so that you can cut the latency and parallelly you can cut the cost. The third solution is all about to use the AWS PrivateLink. So this is something the VPC interface endpoint for the backend service, allowing the front-end service to communicate with it privately without going through the internet or NAT gateway. This ensures high, secure and low latency connection. However, this solution is more expensive due to hourly or data transfer charges for the interface endpoint. So when exactly you have to use? The private link is ideal for compliance and security critical use case where keeping a traffic private is mandatory. So how exactly this is expensive? The endpoints are built per hour and per GB of data processed, adding significant recurring cost compared to use the internal ALB. While it eliminates the internet dependency, it doesn't reduce the NAT gateway cost for other traffic unless fully replaced. Additional cost is all about it has 0.01 cent per hour endpoint and 0.01 cent per GB of data processing. Net saving is all about low cost saving suitable only for the high security and compliance need. Look into this particular diagram. So where you have an NLB and ALB. ALB is mainly used for where exactly the client will access the service by using the frontend.test.com. So request will route it to Route 53 and it goes to internet gateway and it goes to the public subnet where we have ALB placed. And the traffic will go directly to the front-end service. This is only for the client applications. Basically, the users, the clients, the customers will use this particular route. If the backend service wants to communicate to the front-end service, how exactly it will happen? So here we have to create two things. One is called VPC endpoint service and another one is called VPC endpoint. The first one is you have to create as an endpoint service. What you have to create as an endpoint service? Your front-end service has to be created as an endpoint service. How you will create? So you have to create it by using an NLB. You have to deploy one NLB in the public subnet and then you have to map it to the route the request to the front-end service. And from there, and you have to create one VPC endpoint service. VPC endpoint service is the service that it requires an NLB and then you have to give your VPC details, subnets and all those things. And then which account is supposed to use, which VPC has to use. Those things you have to define it in the configuration. Once it is completely done, you will get an VPC endpoint service. So once you get an VPC endpoint service, that service that you have to take it and you have to create one VPC endpoint in your private subnet. So once you create a VPC endpoint, you will give you one clear VPC endpoint and URL. It will be resolvable within your VPC. It won't be exposed outside of your public network. You can use those the endpoints to communicate to the front-end service. Quick summary, the placing the ALB in the same VPC is the most cost-effective solution for reducing the latency. Using the service discovery in ECS is another cost-effective option to simplify the service-to-service communication. If your use case demands strict compliance or security, consider using AWS PrivateLink, but be mindful of the higher cost. Optimizing the private to public service traffic isn't just about performance, it's about the balancing the cost and efficiency. Choose the solution that fits in your architecture and the business needs. Do you want to get more content like this? Then you have to subscribe my channel. Please do subscribe it.